Like a year ago, I did a video on, actually a two-part series, I guess, on how I get started checking refrigerant pressures and what goes through my head as I'm trying to evaluate a system. So I didn't realize how much time had passed, but what I'm going to do today is go out and look at a package unit and put the gauges on it and run through those numbers again, show you a couple things about where you hook up and what particulars there are involved with that particular spot in the line. So just try to explain a little bit better and actually get a real unit to look at and put those numbers on. So we're going to jump out in the shop.
All right, so here we are on a single stage heat pump unit, and this is of course a package unit. It's one of the ones I've done videos on in the shop before, I believe. If not, this is going to be the first time. So but what I've got here is I've just rolled it into a position in the shop and took the corner cover off. And this is typical of a lot of units. Right here on this side corner is your compressor area and your indoor metering device. If you look above it, I've got a refrigerant accumulator, and I've also got the filter dryer in the liquid line back here. Right, this panel to the left is an access point to the evaporator coil. And then of course, if we went any further that way, that would be where the return duct would be. You would have your crawl space area over there with the ducts going through and underneath the lintel and the foundation. You got your shroud over the ductwork to keep the water out. So we're going to look right here, and specifically we're going to take some gauges and hook up and talk about why we're doing that and what numbers we're going to get. So I started the unit just a second ago, so it'll take a few minutes to warm up. We're not going for picture perfect because we're inside. It's a beautiful day, of course. Inside it's like 72 degrees in here, so the numbers won't be exactly what you would expect out in the field, but you'll get the point. So when you open up a package unit, somewhere, somehow, okay, and there's a few different ways, but in this particular one, this is a ICP product, and when you take this corner cover off, you're going to see two access points, and I don't know of any package unit that doesn't give you just two, and they're usually close to the compressor. If not directly, then through the use of a capillary tube type through the use of the capillary tube, they'll extend the point that they tap in close to the compressor out to a panel, that's easy for you to get to. In some cases, they actually will cut a little hole in the service panel so you can run your hoses if it's not in an area like this where it doesn't matter if this corner cover's off, because there's no airflow going to get affected over the evaporator or the condenser, mainly the condenser. So what I'm going to do here is, if you look right here on this left-hand side, this scroll compressors, the discharge line on the scroll compressor is at the top. So as we look right here, and you have to know what type of compressor you got this weld line right here, you got your scrolls orbiting and stuff right here, compressing the refrigerant vapor, and this line over here is our discharge line. It's warm where the rest of the compressor is cool. That line is going to be the hottest temperature point, or the compressor is going to be the hottest temperature point right here, and that line is going to be very warm. And if you look and you follow it, a little serpentine effect, there's an access point there. That's going to give us our pressure for the high side of the system. So I'm going to take that cap off, make sure it's got a little O-ring in it, and I'm going to put my high side pressure gauge, I'm going to hook it up there. Now the other side, since we've already taken care of the high side, we got to take care of the low side. So you can follow that line from the lower portion going into the compressor. It's around back here, but if I follow it, it comes out a couple inches and curves up, and here it is right here. This is my vapor line coming from the evaporator. All right, this is that low pressure, low temperature vapor. It's going to be superheated, and they give me an access point right there before it goes in the compressor. So if it ain't superheated here, you really don't have a whole lot of room before you put liquid in the compressor. All right, once again, brass cap, and we're going to make sure that we have a O-ring in it. And this is where we're going to hook up our low side. I've got a set of Yellow Jacket digital gauges here, and what I've got to do is I've got to actually get to the right refrigerant, which is R410A for this unit. So I'm going to cycle up. Oh, too far. There we go. And as we look at it, if you remember what I mentioned in the previous videos and stuff, there's two numbers that I use to get started in this. One's going to be the outdoor ambient temperature. That's going to be the temperature over the condenser coil. And the other one is going to be your indoor return temperature. And without getting into wet bulb and stuff like that. But this is, you know, basic general stuff. So for what I'm going to do here, the best thing I can do is take a return temperature outside through this panel here. I'll show you that in just a second. And I'm also going to take a condenser coil temperature. I need to know the air temperatures entering both coils. So hang tight, I'm going to move over there and I'm going to show you what I would do. All right, so here we are just around the corner from the compressor area, and what I would do is I would take my little air thermometer and turn it on and stick it right here by this side, especially if it's not in the sun. You don't want like a direct sunlight reading, but if you could either shield it or put it on a side of the condenser coil, because this whole top is the condenser coil, right? So somewhere around the corner would be a good spot, whatever. Let that start getting your condenser temperature, or at least the air going over the condenser. And then what I would do is I would take like one screw out. I've seen guys drill holes in the side here and, you know, use that for an air temperature port. But usually if you take a screw out, and I've got the luxury of not having ductwork and having this thing on wheels, but usually if you take a screw out, you can take the little K-type temperature wire that comes with your meter, and you can stick through that hole. Now if you feel resistance, it's probably, you know, the insulation on the inside, so don't push that out. But if it kind of keeps feeding in, okay, and here's the other side, right? If it kind of keeps feeding in, then, you know, with the ductwork being right here, and of course you can't see it, the shroud is going to cover everything, but that little bead on that K-type would sit right there, and that air would just be coming right by it. So it's just something that I've noticed, you know, and it works for me. So try that. And really all you're looking for, I mean, you're looking for the supply and the return, or excuse me, the return temperature going in the evaporator, and also the air temperature going over your condenser. So you get both those numbers that we need to start working this thing. So, and you can see we're about 71, you know, it's going up a little bit, not very fast. So, I mean, if it evened out at 71.5, that'd be fine. And on the outside, like I said, because we're inside, it's gonna be about 71.9. They're pretty close. I've got two different brands, two different types. So we'll take it for what it is. So 71 to 72 degrees. All right, so we're gonna say it's 72 degrees, you know, going in our condenser, and it was about 71 degrees going in our evaporator, all right? So I'm not looking at the gauges yet. Matter of fact, they've timed themselves off. But if we ran through just real quick without breaking out a true whiteboard or whatever, this number right here is gonna help me estimate what I should get. Now I'm running a 410 system, and just, you know, for numbers that I use, I know that my evaporator temperature should be about 30 degrees less than that. So I should be somewhere around a 41 degree coil, the saturation point, okay? That is where the heat from that 71 degree return air is going across that evaporator coil, and we're changing state from a liquid to a vapor, okay? So I should have about a 41 degree evaporator saturation temperature. Using the other low side rule of thumb, or the rule of thumb that involves the air temperature, if this unit is on point for proper charge and airflow, which airflow we're not getting into, we're assuming is perfect, that temperature, right, I ought to be somewhere around 51 degrees. Don't know why I put a decimal there, but in my mind I was doing it. So if I got about an 18 to 20 degree drop in my air temperature over that evaporator, I'd be happy, okay? If I got a 41 degree saturation point on this evaporator, I'd be happy. So what I'm gonna do is I'm gonna turn it on real quick and get both these gauges back on. And we'll finish up with the condenser before we look at the gauges and talk superheat subcool. So 72 going in this condenser. Step right here, look at the model number. If I'm not mistaken, this is like a 14 SEER model. Just offhand real quick, you could research your own personal model number or whatever you're at looking at the time, but condensers always have to be warmer than the air that's going over them. Evaporators always have to be colder, so I have to be warmer than 72 degrees for my saturation point. With the 14, 15 SEER, you know, we're gonna add about, let's see, what are we talking about? 15 to 20 degrees? So if I worked in that range, I would expect on a high end maybe 92 degrees for my saturation temperature, just as a starting point. Of course, this is all, you know, just a rule of thumb, giving you something to put in your mind. So let's look at it real quick. All right. So I've got my gauges here, and it went back R22. Boy, I tell you. These are nice little yellow jacket gauges, but when they reset, they go off, all right? So I'm looking at 114.4 PSI and about a 35 degree coil, all right? Saturation point, that is. And on my high side, I've got 248 PSI and about an 80 degree coil. So if I fill in that number here, man, I'm 80 degrees on my saturation point. I'm still higher than the 72, but I'm not where I thought I would be. All right, for my evaporator saturation temperature, it's actually fluctuating a little bit. I'm at my 35 degree point. All right, so maybe they both maybe look a little low. All right. But what do you do with that number? You can't do anything with that number yet. You need to actually check your superheat and subcool. So where do you check that? All right, if we come down here back to the compressor area, what we need to look at, is the superheat and subcooling points we need to check. So I've got a pipe clamp right here that I'm gonna use. This line that we looked at earlier, I refer to it as the vapor line. This thing is cold and wet, and it's got a little bit of oil on it too. But it is going into the compressor. That's the vapor line from the evaporator side. So I know that that is where I need to check superheat on, or for. So I'm gonna use my pipe clamp here and check that. It just happens to be the same area, the same line, where I've got my low pressure gauge hooked up. So I'm gonna put that there. I'm gonna bring my fluke meter over here, and I'm gonna check this particular line. And even though it's off screen a little bit, right? Might as well show you already. You can see up here, I've got a 34.5 degree coil or so, and I've got a 45 degree line. So my vapor line right here is 45 degrees, almost 46, okay? So I know I've got superheat. I can do the formula now and figure out just how much. All right, so as we're doing this, you can see I've got a 45 degree vapor line and a 35 degree saturation temperature. What that's going to give me is 10 degrees of superheat. Okay. We could flip around and do another check for our subcooling. Now, when you've got a package unit like this, my high side connection, a lot of people think, well, I just hook on the line where my hose goes. And you have to understand that this compressor, the line that we looked at, okay, the discharge line's coming out of this compressor, and about, I don't know, 8 or 9 inches later, not even a foot, they give us an access point. That access point to the high pressure side will give us the high pressure reading we need, and the pressure temperature chart will jump in and take its proper place here and say, at that pressure, this is the saturation point. So right now we currently have 247.5 psi. That gives me a saturation point of 79, almost 80 degrees. All right, if I were to clamp that line, you're not gonna get, and it's a little harder on this one, as with a lot of package units, right? So let me get up in here. If I were to clamp that line, you can easily see that, I mean, we're going up almost to 120 degrees. Subcooling is not an increase in temperature, it's a decrease in temperature. We're cooling it, we're taking the heat out. So you have to realize that that discharge line is a high temperature, high pressure vapor. The whole job of the condenser is to reject that heat from the evaporator and the heat of compression in that compressor and get rid of it. So that 118, we're not just gonna do the big number, subtract the small number, because we wind up with almost 40 degrees of superheat. Subcooling. Superheat is always at the end of the evaporator, and subcooling is always at the end of the condenser. So you have to know where the end of this condenser is. So the easiest thing for you to find in this package unit here, to identify the end of the condenser, is know the next component in the flow. My next component at the end of the condenser, as we look at it in like a paper example, a 2D representation, the condenser always flows to the metering device. And right here you'll see that you have a TXV on this system. So I've got a 3/8 line coming in, and I pretty much have a 3/8 line coming out. You get lost in all the panels and the turns and the twists, but it's fairly easy. One side, you'll see it kind of has these distribution tubes from that distributor. That's going to be your evaporator side. That's going to be cold and probably a little clammy feeling, a little wet, you know, condensation on the line, and we have that here. The other side is just going to be a warm liquid line. This is the line where you can put your pipe clamp on there to get your subcooling. Subcooling, by definition, is going to be your condenser saturation minus your liquid line temperature. So we look right here, you can see now I've got a 71, you know, between 71 and 72 degree line temperature. That's the liquid line. So if we had an 80 degree coil before, all right, and then we get this 71.5 degree liquid line. Well, I've cooled down below saturation, so we could easily do the math and figure out our subcooling value. 80 minus 71.5, you're going to be looking at somewhere of 8.5 degrees. Okay, so don't use the number from the discharge line. It doesn't do you any good. So 8.5 degrees of subcooling. Is that good? Is that bad? I don't know. Is 10 degrees of superheat bad? The generic rules of thumb are going to tell you 8 to 12 degrees of superheat, you know, 8 to 12 degrees of subcooling. You have to do all your readings. So we've got pressures to go with that saturation temperature. We've got line temperatures. We've got air temperatures. This is what you have to do to get it done. So the only other thing that we didn't verify was this air temperature on the supply. So let's walk around to the supply side of this unit and we'll take the air temperature and see what it is. So I'm around on this side. I've got my K-type plugged back into my meter, and I'm going to do the same thing. I'm going to take one screw off, and for me it's, you know, it's usually the one on the top corner, closest to the back of the unit where the ductwork is. And I'm going to take this, and it's got like a slight natural curve to it anyway. I'm going to take and try to see. See, this one had a little bit of insulation. I had to just barely touch it. It's right at the top where the seam of the insulation from this panel and the top underneath that condenser would be on the inside. So if it works for you, it works. I would not recommend taking your air probe and trying to stick that way. If anything, you're going to go straight into that insulation that's underneath this metal that separates the two halves of the system. So and I don't really like drilling holes in the side. It just kind of looks tacky, because a lot of people, they either use duct tape to cover it up or they don't have anything to cover it up. So it just gives you an access point for rain, bugs, whatever. So if you're going to do something crazy like that, at least make it look good somehow, some way. I'll leave that up to you, but the screw hole's already there. If it happens to work for you, it's good. And as we look here, I've got a 51.1 degree supply temperature. 51.7, it kind of bounces a little bit, right? Numbers move just ever so slightly. That's pretty good. 71 going back in, 51 coming out. Let's go look at the numbers. All right, so we estimated that 51 by taking a 20 degree drop off of the 71. That's good. Superheat, subcool, I mean, the superheat's good. The subcooling, I mean, it's okay. We were a little low on our saturation estimation. I can't tell you about that. I was a little low on my condenser saturation, so low on both of those. So that means the pressures are going to be low. This is one of those where it, I mean, and probably in my case, because I'm inside and it's so cool and the humidity's down and stuff like that, but you're going to come across a spot where you're using a troubleshooting chart and you've done your basic checks and it looks good, it feels good, but then you get this weird thing like my saturation temperature is off. That's going to be where experience comes in and teaches you. Sometimes there's not a perfect answer. You have to make your best estimated, educated, you know, do right by the customer. You have to make that call. I wish there was a better way for me to explain it. Sometimes you get a call back. Sometimes, especially if you're there for a cleaning, if everything's been working right, you're just there to do a filter change and some coil maintenance and stuff like that, you probably don't have much to worry about. If you're there because it was a problem, you know, and you don't find anything electrical, then yeah, you got to do some digging. Maybe there's an intermittent problem somewhere. But my big thing for right now, do your numbers. Time will get you there. You got to know where to get your superheat subcool stuff. So if you can identify what you know, all right, find that metering device. It may be a piston. In our case, it's a TXV. So I know that liquid line ends at that metering device. And I know it came from my condenser where I rejected heat and it should be liquid, okay? Another thing, usually right here by this blower compartment, you're gonna see the vapor line, okay? So mine is, I mean, and besides that, the TXV bulb is strapped right here. If it came from the factory, it's probably in the right spot. You never know what you get sometimes in the field, but I mean, that vapor line being right here would be an acceptable spot. It's only a couple feet further to the pressure, the pressure tap. So pay attention to what you got. Look around. And definitely don't use the discharge line unless you're just wanting to see what it is. But don't use that line for your subcoolant. I got one more unit I'm going to show you and just give you a different view on it. All right, we're going to do a different package unit this time. Same concept, different set of gauges. We're going to run through it real quick. But I've already got it running for a few minutes. Another scroll compressor on another package unit. I've already taken that corner off. I'm kind of going to do the same thing. But this time I'm going to use the digital set of gauges, a digital manifold. It's going to be the Fieldpiece SMAN. A lot of guys like this. I get some new guys that they just don't understand how to read it. So once again, as you're looking in this area, I know my compressor's here, and there's no obvious pressure taps on the outside for me to get to, so you have to take this cover off. And right away, I see a compressor. I see a brass cap, another brass cap here. I see this big brass body. That's my metering device. So this is going to be my distribution area. You can see how it splits into 3 tubes on this one. The last one was 4. I can notice that my TXV capillary goes up here to the bulb. So that better be my vapor line. If you don't trust it, look at where every time you get this distribution area coming out of the metering device, it splits 3 times and it goes into each section of the evaporator. They all come back, and right here, right on this panel area is a larger vapor line, because vapor takes up more space than the same amount of liquid. So that is my vapor line. I'm going to check superheat right here. My pressure tap is right there for my low side. And once again, I got my O-rings in my brass caps. They give us a high port, warm on top of the scroll. My scrolls are compressing like right here. So the discharge gas is coming out, discharge vapor. Compressor's a vapor pump, you gotta remember that. We don't like liquid in it. Scrolls might can handle a little bit, but they're definitely better than the old stuff, right? So I've got another brass cap right there. So I'm gonna turn my gauges on. I think I'm gonna turn my gauges on. There we go. I'm gonna take my low pressure. I've got some refrigerant in there, so I'm not going to open this up. I'm going to put that on, open the valve for my low loss feature. I'm going to take this one, high side, that's going to be on my discharge. There we go. Turn it on. Now, if you've never seen the SMANs, which I don't know who hadn't already, but just in case you're new and don't have digital gauges, this one actually comes with built-in pipe clamps, whereas the last unit I had a pipe clamp that would, with an adapter that would plug into my meter, since I had a temperature function on my meter. All right, so whichever, doesn't matter. The good thing is this guy will do the math for you if you tell it the right numbers. So wherever you put these clamps is where you're telling it. This is on the low side of my system where the pipe clamp plugs in. So this is going to be for my superheat. And you can see here it's already reading superheat, and I haven't even touched anything. If I put it on my hand, you're going to see the superheat change. Oh, 30, 40, you know, whatever it's going to be. Okay. We have to put it on the vapor line. So I'm going to clamp it right next to what happens to be the access port on my vapor line. I've got another pipe clamp, and this one's going to be dedicated for the hot side. So we're going to be doing subcooling with it. So I'm going to unloose all this this cabling. Got to make sure you keep it straight. So I'm going to take this one, and even though it's already reading superheat, it's because of the air temperature. You can't stop it from reading the temperature. You have to put it on the proper place. So we're going to go right down here. We're going to go right down here, and just like before, there's that liquid line. I've identified my metering device. I know that's where the pressure goes from high to low. So find the hot side. You can grab it, it'll be warm here. On the other side, it'll be cold. Even if it don't feel warm, if the other side's cold, then the first side's warm, right? So we're gonna take and we're gonna clamp it right there. And it's a little loose. What you could do is take a piece of insulation. If you felt you weren't getting the proper reading, you could take a little piece of insulation or something and stick under that, and it should kind of tighten it up. So I'm gonna do that, so hold tight real quick. Now, don't go tearing up grandma's unit, okay? Usually a lot of service guys, they've got some extra Robotex insulation somewhere in their van for when they're doing metering devices like TXVs, where you can re-insulate the bulb and such. So don't tear it off of the line set if you're on a split unit. Just go grab you a piece, you know, carry you a few, you know, a couple feet of it, stick it in the corner of the van door. But I mean, you can reuse this. We're just gonna we're gonna put that in there on the side that's not the temperature, okay? And this way it should let it sit a little bit tighter against that liquid line so we get a good contact temperature, okay? So, because I moved over like 10 feet, like the temperatures are still gonna be the same, so I'm not gonna bore you with that. So I've got about a 71 degree, man, I did it again, 71 degree return, and I've got about a 71 degree ambient, okay? If there was any doubt, of course you could just go around the corner here, and I've already taken the screw out the same corner just like I did on the other package unit. And if I feel it feeding in, you know, you gotta bounce it around a little bit. There we go. Yep. And about a foot, 14 inches in, the weight of that lead just kind of lets it down. So I could easily double check it. Take my handy dandy thermometer here and put it up there. But like I said, we're still looking around the 71. There's not but a degree difference, so that's really negligible. So we'll let that ride. Now what does that mean, once again, as we estimate what's gonna happen with our pressures and stuff? What are we looking for on the condenser? What are we looking for on the evaporator? Well, this is going to be another 410 unit, so I would hope that I'm about 30 degrees colder. So if I was, that would give me about a 41 degree evaporator. The SEER rating dictates the condenser. This one is a 15 SEER, so I would hope that I'm about the 90 degree mark, 91, you know, we'll say. So you won't know until you put your gauges on there. All right. So, and if we look at this one, it's just too pretty on this one. As we look at this one, there we go. You can see that we have on our low side, we have 100 and almost 32 PSI. The saturation point for that pressure for 410 is going to be 45.5. Now we expected about a 41. We're a couple degrees warmer, so you know, give or take a degree. I mean, we're in the ballpark. To me, we're better off than the other unit. We were low on that other unit. We were in the 30s, 35. So it says here VSAT. This is your vapor saturation. That's a reference to your evaporator. Okay. This middle number here says SH, superheat, and you can watch it go up and down. This is to me is the beauty of the digital gauge. I can see small changes, and what you'll notice is our numbers don't really stay the same. They kind of have a little roll to them, a little flow. So this superheat, it doesn't tell you the vapor line pipe temperature. It tells you the saturation point for the given pressure. But wherever you clamp that pipe clamp, right or wrong, it's gonna do math. And it knows that the numbers it should be working with is a vapor line temperature on the low side going from the evaporator to the compressor, that number better be higher than the saturation point, okay? If it's not, you don't get a superheat reading. Superheat does not go negative. It's either 0 or a positive value. So you can tell ours, this TXV is going to open and close, and we've got heat going in and out through the air, through the blower, pulling air across that coil. But you'll watch your superheat move a little bit. You don't see that on analog gauges a lot. All right, you would have to really be good and monitor it. So this is good. So right now, 10 degrees of superheat. If my saturation point is 45.5, 10 degrees higher is my vapor line temperature. So I've got a vapor line about 55 degrees right now, and it's falling. Looks like some of that refrigerant as it's being pulled through by the compressor. I mean, it's falling quite a bit, almost 8 degrees compared to or what it did just a second ago. So it was down at 2 degrees superheat. So we're right on the money with this, I believe. The condenser side, this being a 15 SEER according to the model number, 71 Fahrenheit, right? We're gonna add about 15 to 20 at the high end. We should have been around 90 degrees, 91 degrees on my saturation point, and I am. I mean, 89.1, I mean, that's pretty close. 271 PSI gives us an 89 degree saturation point on our high side. So this is where we're actually taking enough heat out of that vapor, that superheated vapor in the discharge line. It gets into the coil, and we turn it back into a liquid. So that's the point. Subcooling. Subcooling values here in the middle. It knows the liquid line has to be colder. If it's not, if you hook it on the discharge line, which I'll show you in a second, and that's the point of pulling this over here, it knows that these values, it's got like a spreadsheet built in, right? It knows where to put that number you tell it on that pipe clamp. If you put it in the wrong spot, it doesn't compute right. So it knows positive 15 right here. The liquid line is 15 degrees colder than your liquid saturation point. So we've got a liquid line somewhere around the 75 degree mark. Watch what happens if I put it on the discharge line. Watch our subcooling numbers. Oh man, I mean, it's going negative hard, right? So minus 22, it says below typical range. There is no negative subcooling or negative superheat. Know the numbers you're supposed to get. Know where, because it's not just put the big number on top and do an easy subtraction problem. Superheat, vapor line, minus your evaporator saturation temperature. And subcooling is the saturation temperature of your condenser minus the liquid line temperature. If you put it wrong, you get these fancy digital gauges and it says negative 26, and that ain't nowhere near right. So put it in the right spot and this thing will easily pick it up. Let's look over here. I've got a 71 degree return air temperature. Let's go see what our supply is. All right, real quick, like I said, already taking the screw out, save a little time. If I put that through there, it kind of feeds like right in. All right. And this is a gas pack unit, so I've got a heat exchanger right there. But that heat exchanger, you might feel a little resistance if you hit one of those cells or something like that. But as we're looking up top, I got 71 going in, and I'm already at 53, and it's dropping a little bit. So if it stops, around the 51 or 50 degree mark, then we're in the money. I would leave the charge alone and let this unit ride. So yeah, we'll call it at 52. So that's how I would actually, on a package unit setup, actually look and realistically get the numbers. Package units are fairly easy. Split units, I mean, heat mode, cool mode, if it's a heat pump, you just got to watch where you put your stuff. It's not always on, like I said, it's not always where you put your gauges that you take the line temperature of that spot. So it just happens to work out in our case that the low side pressure point or connection was where the vapor line, where we needed to be. And package unit, that heat pump over there no matter if we're in heat or cool mode, the reason they give you those 2 ports and only 2 ports is it's always high and it's always low. So hope this helps a little bit. Gets me back in the shop and doing some things, but yeah, 52 degrees, 71 going in, 19 degree split. We're all right today. And so here is a unit that we've got to yet be installed anywhere, but on this package unit, this is a Rudd Achiever. So different brand name. It's not a Goodman. Goodman, you're going to take the panel off more than likely to get to the compressor, just like the package unit we just looked at. But on here, you can see we've got 2 plastic caps, and underneath those caps, just you know, this is the access point. They actually label them high and low. So the one that's on top is the high one because it's higher, and the one on the bottom is the low. So you can have a access port that is on a kind of a exterior wall like that, but behind it they're just going to run a tube and connect it into the system on the low line and the high line. Okay, so if it's a heat pump, it doesn't matter. They're going to find the common low and the common high side. So that would be, in the case of a heat pump, it would be between the reversing valve and the compressor for the common high and the common low. So it just depends on which one you're trying to get to. But yeah, that's just another example of how it would hook up.